We're going to discuss the Decade Box utility. This is a fairly extensive utility and is quite heavily used. It allows you basically to calibrate Decade boxes, and although there's some manual intervention because the Decade box, well, this being a Decade box here, as an example, has the dials that have to be turned, so that can't be automated. However, there's a lot of configuration for setup and test parameters for the bridge, and picking reference resistors that will work for the appropriate ranges in a Decade box. That can get very cumbersome and difficult to manage. So there's a utility that's been designed and put into BridgeWorks to help simplify the process, where basically you just have to define the Decade box itself, and it'll tell you what standards you need. You tell them what values are assigned to those actual standard values for its traceability, and then you can click on go and it'll just prompt you when you need to turn the dials, and it does the rest of the setup all by itself. So we'll go through the process on how to set this up. So Decade boxes are typically 2-wire devices, and so we'll find a free channel. Here I have channel 32, and of course you bring your C1 and P1 together, and you place that into one side of the Decade box, and your C2, P2 into the other side of the Decade box here. Like that. And make sure that your Decade box is all set to 0. All the dials. And then you go to software and you'll launch the program. Go to configuration, Decade box, and you'll be greeted with this window. The first thing you'll notice is that you'll see a bit of flashing going on here and that sort of thing. And that's actually part of the prompting system to tell you what standards you actually need to use to calibrate the Decade box. And so we begin with looking at the Decade box and its ranges. So I'm starting here. This Decade box starts with 0.1 ohm per step, all the way up to 10K ohm per step. So we have to tell the program that that's what the range of the Decade box is. So again, in the program, it's 0.1 per step to 10K per step. Put in the serial number, model number. This is DSI DB62. And the asset ID number is 4301. And essentially, what you have here is this is the range of your Decade box, and you'll notice that now we have a few other lights flashing over here. This is telling you that I'm going to need to use a 1 ohm resistor and a 100 ohm and a 10K ohm resistor to make this calibration to cover the entire range of the Decade box. So we will load up our 1 ohm, our 100, and our 10K. And now you see that the lights will stop flashing because now that it's got the sufficient data. Then you will look here and go through different ranges of the Decade box, and you can see here I can index up to 6 ranges because that's how many dials are on the Decade box. You can see it's indicated there. And what you have is you have to outline how many steps. Now the steps, of course, is the maximum number of steps on a dial here. So this one has 10 steps per dial, and all the dials are the same. Some Decade boxes will have 11 steps on the very top or the very bottom dial, and some have only 9 steps per Decade. So you have to pay attention to that as well. And then there's a specification for accuracy. The accuracy is usually found either in the specification sheets, like the data sheet, or the appendix in the manual will give you the specifications, or if they have a calibration procedure written in the manual. And sometimes you just have your own in-house procedures that will tell you the accuracy you're looking for. And what that will be usually rated at a percentage of nominal as opposed to actually an uncertainty budget. And so these will be entered here. And you can choose reversal rates and sample depths. Again, these are not very accurate devices. Most Decade boxes are 100 ppm, so they're quite relaxed in their specifications, so that you can run the bridge much faster than its usual speeds for full rated accuracy, and still achieve very useful numbers with for a Decade box. So that being said, we usually run about 20 samples here, as you can see by default, to just run a reversal rate of 20 seconds. Now this control window that's listed here, what that does is the software is going to monitor the last 5 readings, and those last 5 readings will be checked against what's expected for the value of the decade box. If that 5 samples is now falling itself into tolerance and it's getting the same reading and it's well within tolerance 5 times in a row, then it just moves on to the next test without finishing any more data. And this is just meant to speed up the process as much as possible. Because with a decade box, with 6 dials here times 10 steps on a dial, we're looking at 60 measurements to be made here. So that's a lot of measurements, so you want to move this thing along as fast as you can, especially when you don't have to worry about as much accuracy. So when all this is set up, if you click on Start, the first thing it'll do, it'll ask you if you want to update or if you want to make a new test, and I'll select New. And then the first thing it's going to tell me is do I want to run a 0 ohms measurement? And this is something that I brought up earlier about setting all your dials to 0. Most decade boxes have a setting for 0, and that setting will have some nominal value of resistance in it. And the point is you're supposed to zero that out, and you have to know what that value is. So you would want to hit cancel here. I just wanted to bring it up as an example. There are a few decade boxes that don't actually go all the way to 0, and they will have a nominal value on the lowest dial, and they'll be a step of 1 at that point. And those ones are called direct reading, and you would not do the 0 ohms measurement for those. So I'm just going to hit close here. Essentially, to run the 0 ohms measurement, it's a separate test in the utility because some decade boxes use it and some don't. So in this case, we're going to use it. And to do that, you just basically click on this Go button here. And it'll automatically bring up a window here. It says what you want to use for your parameters for the 0 ohms test. And I'll stick with the defaults because that's usually quite good. And hit Go, and the measurement will start. And what it'll do is it'll actually measure the 0 ohms value, so you can take that offset out of your all your measurements subsequently for this. This becomes very important for the decade boxes that are having steps that are from 1 ohm and below, because the 0 ohms measurement will play a very large effect in the offset to the lower values of the decade boxes. When you start talking about 10K per step or 1 meg per step, not such an issue. So when the 0 ohms measurement is complete and you've established that value, then you can basically go ahead and launch the remainder of the test. And the remainder of the test, you basically click on Start. And the first thing it'll do is provide you with a prompt here. It tells you essentially to set the first dial on the decade to its first step. And so you see it indicates here, you're trying to get 0.1 ohms on the 0.1 ohm per step dial. And so that would be, of course, the lowest dial here. It's moving out to 1. Now it's in position, this resistor is set. You just click on OK, and the measurement begins. And essentially each step takes usually just a few minutes, and it'll prompt you with another window and an audio prompt so you can hear that if you're working across the lab or whatever else, and come back and just change it to the next step and click on OK, and it'll just keep cycling through that so you can go ahead and do other things and be about your day while the decade box is just carrying on. It'll just prompt you every time it needs the manual intervention to turn the dial. So when the test is complete and you've gone through all the dials of your decade box, you're basically ready to view a report. And so we'll take a look at a decade box report example here. So again, click on the report button, and you can choose current or previous decade box, because they can be saved and reviewed at any time. And so your decade box here, you can see you have up to 8 dials, and depending on how many dials the decade box has actually been measured, it'll populate the report accordingly. So if you only measured 6 dials, then the first 6 dials will be populated full of information. And it'll essentially give you a global status on the range. So it says intolerance, that means every step on this entire range was deemed to be intolerance as measured by the bridge. If for whatever reason you see one that is out of tolerance, you might want to figure out, okay, well, why did that go out of tolerance? It may have been one of the steps. It may have been the whole range was out of tolerance. And so to do that, of course, you would look at the details here. And the details gives much more information. You can see here, gives a full uncertainty budget, a calculation, the nominal value, and step-by-step for each element in each range, the tolerance and the status of it. So you can see here, this is decades 1 and 2, and up at the top, you can go to decades 3 and 4, and see the same report, and then decades 5 and 6, they again see the same report. So essentially, you have all the way up to your 7 and 8, all the decade ranges, and you can see a full set of details that correspond to all the measurements made on this decade box here. And then you can diagnose as to which one was out. Maybe you had a bad element, you might want to recheck that one particular element just to make sure it's okay, just depending on the switching. Maybe you find out that the entire dial is not up to snuff, and that's probably because maybe there's some contact issues on that dial. It helps you just diagnose the problems if there is any found on the decade box. And that's how you utilize this system. So again, you can print out the reports and you can save the data as well. And lastly, that's also important, is you can save here in this window. And when you save in this window, you come up with a box file. Now this box has no data. It's actually the configuration. And so I'm going to write an ESI. It's DB62 is the model number of this decade box, and that's what I would save it under, because what this is a profile of the decade box, so that anytime you're ever going to measure this decade box, all the specifications that are outlined here in the decade range setup, and all the parameters that you have in terms of its range and its operation are all stored here, so you can call that back up as a procedure at any time. So that way when you do work on many ESI decade boxes as an example, you can just bring up that profile, make a measurement, but you'll save the data uniquely to the serial number of each decade box you would measure. And that's how you utilize this utility to save yourself a whole lot of time.